Good morning. Today we're out at Thana 7, going to be doing a slab level check. Go around, we'll do some spraying, and then once I finish I'll go through and we'll explain what we're doing. Basically what we sort of do a bit differently is normally from this slab stage you book your carpenters come in and do your frame. And they do these mark outs and then stand all their walls up, and then that's when you sort of see, where there's plate overhang or where there's some potential things that need to be rectified. We sort of bring that process more forward, and so you can sort of see by the mark outs, we're already marked out where all our walls are going. So we can sort of see if there's any issues early on for plate overhang or things that we need to get rectified from the concreter, or normal rectifications, but trying to get it done sooner, ready for the carpenter. In addition, your slab's always going to have ups and downs. Now, you're always going to be going for your checking for tolerances. I just found, especially with our slabs, because there's lots of split level, lots of complexity, but then also just general tolerances. You're pouring a slab. There's mud, there's board, there's pods, there's concrete trucks, there's people crawling everywhere. That you're going to get these ups and downs. And then when you put a wall on that, that wall is just going to follow those ups and downs. Like anything, something that's say 4 mil out here, and once you stand something on it, is further out up at the top. So we've introduced this process where we go through and spray out the slab. We can then see quite visually where the ups and downs are, and then all the high spots we go through and get a floor grinder to grind them level. And then the low spots is then something for then the carpenter to visually see that when they're putting their walls up, that's the areas that they need to pack. So the whole idea is, instead of just really looking at what the standard tolerance is and just going, okay, we're just going to manage it through the process. Sort of putting that wall on it, now needing just that wall to then get it back within level, then put another roof on top, and is really focusing on the foundation on getting it dead level. So we're setting up the level. These levels, they come with a tripod, and you put them on a tripod, but we've been told, and which makes sense, is the lower you've got them, the lower you've got the staff, the more accurate they are. So if anyone's asking why have you got the lasers on the ground, well, that would be right. I'm a very visual person, so I prefer to use the colours to show, the green is to show low points and the pink is to show high points. Setting the laser, this laser level, exactly that, it shoots a laser out at a level, and then this receiver picks up that laser's position versus anywhere on this slab. So if you have a look here, you can sort of see here, this is 0, it says 0, well, I'll see it says 3 mil now. You see that number? And then it's got an arrow pointing up. So that just means from where that laser is, from that position to this position, is 3 mil difference. That's how a laser essentially works. So I create what's called a TBM, a typical benchmark. It's essentially an area that we're going to say, okay, we're going to work from this particular point. And then you make that 0. Okay, so that's 0, which you can see there. Now I'm just going to do a general walk around, because what we want to do is, we've just made that point up. So then I want to go around and want to find out, okay, where is the highest and the lowest points, and then work out what is the most that we have to grind, and what is the most that we have to fill. It's up 6. Yeah. So I go to sort of each 4 points of the house first. That's 0. Okay, not bad. From front to back, we're talking about 6 mil. So wish they were all like that. All right. when you're setting out a house, there will be a TBM marked out the front. And what we do, which a lot of builders will always work off from a nominated TBM out the front. And then when you think about, from that distance all the way to the back, if any of the slab is within tolerance but is different than the front, then you're always working to that front point. And you're always trying to work over the length of this house to from the front to the back. But marking an internal TBM is a more accurate, more relevant TBM that suits the house. So more importantly for steel supply in particular. So you got your chippies will stand the walls up, and sometimes the steel's already done and the steel is working off the front TBM. So any discrepancies through the slab causes a few clashes. But if we nominate our own internal TBM, everyone's working off the same one, and gets the ceilings a lot more consistent in height. So the reason why I go roughly a metre is the whole purpose of doing these levels is no doubtly to get it within tolerance, and tolerance is 4 mil in 2 meters. So doing it at 1 meter spaces, it shows you a pattern. So if I did this in 2 meters, I'd see that it was 2 mil there and then 2 mil there, and you go, okay, well that's flat. But doing it in the 1 meter can show it dips a little bit. Now you look at a ruler, we're talking about this. All right, so that's obviously pretty flat, but at least it visually gives you can see in the colors, pink is high, drops low a little bit, pink, and then low. But all in all, that's you put a straight edge on that. It's pretty impressive when you think about concreting. Like, this is not a car metal pressed perfectly welded on a bench. Like, this is poured from the truck, and you look at the other videos, you see all the moving parts in the slab, the timbers, the star pickets, to get that within that, like, it's pretty impressive to get it within that sort of tolerance. So when they're doing their formwork is the timbers and the star pickets, or depending on what type of formwork they're using, but typically it's star pickets and boards. When they're setting their boards, they will be putting this laser on the boards and checking. So that's typically how it should be done, and how you can tell level. So as you can see, when you're leveling, you've got screeds, you've got helicopters, you've got everything sort of you're trying to level to your external boards, and it's very common for plumbing risers to get in the way. So when you look at these levels, you've got over there, you've got 3 mil up from our TBM, and then around this pipe it's 8 mil. So 5 mil difference under 2 meters, you put a wall on that would create a ceiling that was out of tolerance. So that's why it's very important that when we do the slab grind, that will grind around this penetration to take 5 mil off now, and when you stand the wall up, you don't have that discrepancy. So always check in and around your risers. Someone's in the way of the laser. We've all heard the saying, prevention's better than the cure, and that's essentially what this is. It is, instead of putting a frame on this and then working out what our flooring is up there, let's get this dead level first. Let's embrace the fact that instead of going, okay, we get the ups and downs, and then framer stands walls on there, and you go, well, your walls are up and down. It's like, well, I'm just copying the slab, but when the framer's framing, they've got variances in their timber. So instead of pointing fingers at each other and going, no, it's them or it's them, we do this to take out as many sort of variables as possible, and then the carpenters then come along and go, okay, cool, well, not only have you made it visually straightforward to hone in on the areas that are up and down, but also investing in money to make their job easier. You know, that flows through the whole project. It's not just then the walls are straight, it's then the plasterers then go, okay, my cornice lines are straight. You know, the tilers then go, okay, now I'm tiling and everything's just straight. So it's very important. It's a very important part of the process. I say a lot of people is quality is a process, not just a word. So, you know, a lot of people say, oh, we use quality products, we use quality trades. It's like, yeah, you probably do, but, you know, demonstrate that. So this is, you'll see over a lot of these videos that you know, primarily I just live in my office, but then I come out on site to do a lot of these spot quality checks. And then also make sure what we've sold to our customers through the process is what we're delivering on. So I do some spot checks on the garage, but we don't like spraying the slab because, you know, it leaves the marks on the ground. So the chippies and the supervisors know, look, I will then, because see, it's at a different height. So after I've done the house at this level, I then have to change the laser height when there's a step down. So I will then go through and check each 4 corners, and if there's any discrepancies there, then I'll send that through in a separate report just to minimise, you know, again spraying on the slab, so don't you know, wreck the finished surface of the garage. This process is that important. You know, it saves weeks, if not months later. You know, how many times do you see on social media that you know, you miss one of these walls, and just even out of earnest, you're only human. You're putting levels on things and think everything's all good, but you just get one stray wall that, you know, you don't pick up until the end. And after it's painted a tile floor covering, you go, well, you know, you have to rip it off. You know, it's not a good look. You know, a lot of builders know it's an easy fix. Like I always say, you know, construction's 5% structural, 95% makeup. You know, so your slab and frame is your 5% structural. Everything else that goes onto it is pretty much makeup. So it's pretty easy to fix makeup, but it just doesn't look good. You know, when you walk into a brand new house and you rip the whole wall of plaster to get a hump out of it, put plaster back on it, paint it all up, no one will ever know if you don't see it, but you always see it. Looking at it from the client's point of view, you know, it sort of almost feels secondhand. You know, if you cut that bit of plaster, you're like, well, yeah, if that wall was straight, if that was sort of preventable, then, you know, not saying that we don't do it, but the good thing is I can count on one hand the ones that we miss with going through this process, as opposed to, you know, if you don't. Okay, would you say, you know, I'm a short ass, but, you know, that's roughly around about a ceiling height, would you say?
Yep.
So, you know, from here to there, if I hold that bubble level, you know, that's roughly the staff level there. Now, if I move that out at the bottom 4 mil, you know, you look what happens to the top. You know, the top moves significantly more. And that's essentially what we're looking at, a minimal hump at this slab level. By the time you stand a wall on it, you know, how's that affecting up there? And then if you also look at a lot of our designs, and a lot of the in vogue things at the moment is big voids and, you know, feature ceilings and square set, all these sorts of things. 6 meters up there, it's a lot further out. So yeah, doing this now to get it level. The other part that we wanted to make sure with doing this process was this process wasn't only just something we've introduced because, you know, we recognise there was a drop in quality in the industry. You know, not going to tippy-toe around that. But the main attitude that we wanted when we did this and spoke to the concreters was, we're going to do this slab check, giving you the heads up, and the whole intent of this check, as long as there's nothing sort of train wreck and horrific, you know, we're not wanting to actually then nitpick their job and go, oh yeah, that's a little bit of a hump, and, you know, we're not paying to do that. It's not at all. We actually wanted to go be more understanding the variables that they're dealing with, understanding, you know, the variables I mentioned before in, you know, soil conditions. You look at the front there, the mud and crap, weather, all these sorts of things. You're talking about a gang of 10 labourers walking around on things. How many other people have walked on things and stood on things and walked along a bit of timber and it just sunk a little bit underfoot that you didn't feel. All these variables result into discrepancies, and we're then choosing to inject another process and money to grind that flat ready for the carpenter with no intent on hanging the concrete for those variables. So it's easy. The carpenter in me, I've always been spoilt to a degree that then I can come onto a slab like this with not as much mud and start doing my perfect thing. So they've got a tough job to get a slab level. So if we can help with doing this to get it even better, well, that's what it is. So that end was 50. This end's 51. So there's 1 mil in that. So no need to. That wasn't good time for the camera. It's never that accurate, but I'll take it. That's why I do that check first before spraying up the garage slab. This garage is a big open space, so you've got eye line around the whole area. So in and around toilets and bedrooms and smaller rooms, you've got some wiggle room to hide behind what you can see, and put a 2 metre level in. But the garage, which is a non-aspirational area from a design and livability point of view, it's storage, put your cars in, but you see the most of the ceiling. So it's important to get it all level, but garage is also something to focus on. What I'm looking for to grind is those high spots. So looking through the front section here, and also we grind the areas that we believe is going to throw out tolerance. So looking at the front section here, it's all pretty good. This area that I highlighted before around the riser, that does throw us out. So we want to grind in and around this. Mil down, 2 mil down, 0, 2. So it shows that corner does rise up a little bit. So taking around about 3-4 mil off that corner, then you get the difference between 2 mil here, pack the 7, and then back to naught. So you get a difference of 4 mil down to half the 2. But also in particular, this is a big open living, dining, kitchen space. So if you look from corner to corner, these are the things that I sort of talk around and looking, is I look across the rooms. So I'm not too concerned, I'm not focusing on going, okay, this kitchen, how does that compare to the front of the house? As long as it's within tolerance, it's not really relevant. But standing in the room, I can see here, well, I'm 3 mil down from the middle, and then out that back wall, I'm naught, I'm 2. So to have 1 mil over, which looking to be about 10 meters, is what we're targeting. Get them to grind. I wouldn't become a graffiti artist. It's not too pretty, but it makes sense. So mentioning plate overhang, we get the carpenter to what's called flick out the plates or mark the plates. That's what these black lines are. They mark it out with a chalk line, and it's a visual representation of where the walls are going. And what we want to check, obviously when you stand the walls up, you'll physically see any overhang. But by then, it could be 4 or 5 weeks since this slab was poured that we're putting frame up. And to then get the concreters back to then remedy that, then the timing can be problematic. So we do it 2 or 3 days after slab pour, and then let the concreters still have to come back to push the plastic up, do some other little bits and pieces. And it's easy to highlight. If they're coming back anyway, they're always coming back to tidy up. So if we can then go, well, while you're here, here's these other things we've found, then everyone's happy. They're not having to come back again and again and again and again. So looking at this back section, I can visually see a wall is typically 90 mil. And if you have a look at this back section here, so that concrete finishes at around about 70 mil. So we're going to have 20 mil plate overhang. So there's on our engineering detail, there is many ways that you can then treat that overhang. But then walking around the rest of it, that's the only one that I found, which is good. And I can now give the chippies a heads up in the alfresco area out the back. There's going to be 20 mil overhang. You know, they can then 20 mil it will be treated by, I can't remember off the top of my head, but you've got structural grout and whaling plates. So we can at least get the estimators to order what needs to happen for when the carpenter, send an extra order out to the carpenter already. So when they rock up on site, they know they need to do that, and it all happens before an independent inspector. You know, you're front footing it, and always, you know, helps to be a little bit more efficient in getting on top of these. You find, especially in the busier greenfields estates where there's a lot of builders around, I've had a few sort of curious supervisors going, you know, what are you doing? And I've taken them through what I'm doing and going, well, such a simple step can help prevent so many issues later. And yeah, if you're a builder that's curious in regards to what we're doing, hit us up. You know, I'm not focusing on doing this to go, oh, this is our little secrets that we do. I think the industry needs to improve on its quality. And if this is a process that you find, okay, that's curious, what are you doing? More than happy to you know, take you through it. It's just going to help the industry. And when we started this process, there was around about, on average, about 10 areas to grind, and all within tolerance, but where we're choosing to grind. To see there's 2. Most are, I'm finding, around about 6. About 6 areas that we're finding to grind, and that could be they got caught out in weather, more step downs. This one is relatively minimal step downs for a typical Seymour design. I'm loving the flat block. Normally we're dealing with a lot more fall, but yeah, hopefully enjoyed the slab level process today.